Welcome to the new section of this course, Azure Kubernetes Service. In this video, we will take a look at Azure Kubernetes Services and understand why it's a great choice. Let's start with answering the question, what exactly is Azure Kubernetes Service? An Azure Kubernetes Service helps you to create, configure, or manage a cluster of virtual machines and removes the complexity of setting up and managing a Kubernetes cluster yourself. These clusters are pre-configured to run applications in containers. Let's look at a comparison between the two Azure Infrastructure as a Service offers. In this diagram, we see classic Azure Infrastructure as a Service offer, which at its most basic is a set of virtual machines hosted for you on Azure running either Windows or Linux. The core offering consists of two layers, the infrastructure in the Azure Data Center and the actual virtual machines themselves. Infrastructure consists of a series of virtual machines, which are just an abstraction of physical hardware running on a server, isolating parts of the server resources, thereby maximizing the utilization of the physical server itself. A hypervisor is a system that allows you to run several virtual machines on one single physical machine. Virtual machines in IaaS typically host one or more applications, and all of the supporting libraries and binaries, and of course a full guest operating system. So it's quite heavy. And with all of this on board, a virtual machine can reach the size and high gigabyte range and can be quite slow to spin up. This diagram illustrates the new Azure Infrastructure as a Service offer, which has been structured to offer IaaS not based on virtual machines, but based on modern container technologies. At first glance, this image looks like the previous image. However, there are differences. In the infrastructure layer, for example, you will find a container engine instead of the hypervisor. In AKS, the container engine is a Docker engine. Docker is currently the leading open source project for container solutions. In good Azure tradition, the AKS engine is an open source project. If you want to examine the engine internals, or if you need to adjust it to your needs, you can find the complete source code at the link shown here. Azure Kubernetes Service, also known as AKS, makes it simple to deploy a managed Kubernetes cluster in Azure. AKS reduces the complexity and operational overhead of managing Kubernetes by offloading much of that responsibility to Azure itself. As a hosted Kubernetes service, Azure handles critical tasks like health monitoring and maintenance for you. The Kubernetes masters are managed by Azure. You only have to manage and maintain the agent nodes. As a managed Kubernetes service, AKS itself is actually free. You only pay for the agent nodes within the clusters, not for the masters. You can create an AKA cluster on your Azure portal with the Azure CLI or template-driven deployment options such as the Resource Manager templates and Terraform. When you deploy an AKS cluster, the Kubernetes master and all nodes are deployed and configured for you. Additional features such as advanced networking, Azure Active Directory integration, and monitoring can also be configured during the deployment process. To get started, you're advised to complete the Aks Quickstart in the Azure portal or get started with the Azure CLI. Let's look a bit deeper at some of the benefits of using AKS rather than managing your own underlying infrastructure for Kubernetes. For improved security and management, AKS lets you integrate with Azure Directory and use Kubernetes role-based access controls. You can also monitor the health of your cluster and resources. AKS supports Kubernetes role-based access control, or BAC. RBAC lets you control access to Kubernetes controls, resources, and namespaces, and also permissions to those resources. You can also configure an AKS cluster to integrate with Azure Active Directory. With Azure AD integration, Kubernetes access can be configured based on existing identity and group memberships. Your existing Azure AD users and groups can be provided access to AKS resources and with an integrated sign-on experience. To understand how your AKS cluster and deployed applications are performing, Azure Monitor for Container Health collects memory and processor metrics from containers, nodes, and controllers. Container logs are available, but you can also review the Kubernetes master logs. This monitoring data is stored in an Azure Log Analytics workspace and is available through the Azure portal, Azure CLI, or a REST endpoint. AKS nodes run on Azure virtual machines. You can connect storage to nodes and pods, upgrade cluster components, and use GPUs, a very important feature when working with machine learning, for example. As demand for resources change, the number of cluster nodes or pods that run your services can automatically scale up or down. you can use both horizontal pod autoscaler and cluster autoscaler. This approach to scaling lets the AKS cluster automatically adjust to demands and only run the resources needed. Azure Kubernetes Service offers multiple Kubernetes versions. As new versions become available in AKS, your cluster can be upgraded using the Azure portal or the CLI. During the upgrade process, nodes are carefully cordoned and drained to minimize disruption to running applications. AKS supports the creation of GPU-enabled node pools. Azure currently provides single or multiple GPU-enabled VMs, and GPU-enabled VMs are designed for compute-intensive, graphics-intensive, and visualization workloads in addition to AI. To support application workloads, you can mount storage volumes for persistent data. Both static and dynamic volumes can also be used. Depending on how many connected pods are to share the storage, you can use storage backed by either Azure disks for single pod access or Azure files for multiple concurrent pod access. An AKS cluster can be deployed into an existing virtual network. In this configuration, every pod in the cluster is assigned an IP address in the virtual network and can directly communicate with other pods in the cluster and other nodes in the virtual network. Pods can also connect to other services in a peered virtual network and to on-premises networks over ExpressRoute or site-to-site VPN connections. The HTTP application routing add-on makes it easy to access applications deployed to your AKS cluster. When enabled, the HTTP application routing solution configures an ingress controller into your AKS cluster. As applications are deployed, publicly available DNS names are auto-configured. The HTTP application routing configures a DNS zone and integrates it with your AKS cluster. You can then deploy the Kubernetes ingress resources as normal. Kubernetes has a rich ecosystem of development and management tools such as Helm, Draft, and the Kubernetes extension for Visual Studio Code. All of these tools work seamlessly in AKS. Additionally, Azure DevSpaces provides a rapid Kubernetes development experience for teams. With minimal configuration, you can run and debug containers directly in AKS. The Azure DevOps project provides a simple solution for bringing existing code and Git repository into Azure. The DevOps project automatically creates Azure resources, such as AKS, a release pipeline in Azure DevOps services that includes a build pipeline for continuous integration, sets up a release pipeline for continuous deployment, and then creates an Azure Application Insights resource for monitoring. AKS supports the Docker image format natively. For private storage of your Docker images, you can integrate AKS with Azure Container Registry. Azure Container Services has been CNCF certified as Kubernetes conformant. Regulatory compliance is becoming more and more important each year. Azure has the best certifications of any cloud vendor, and Azure Kubernetes Service is compliant with SOC, ISO, PCI DSS, and HIPAA.